Lesson 14, video number 2. We're looking at problems 4, 5, and hopefully 6 in this particular lesson. So, when we're looking at 4a, okay, we have the sine of x plus the sine of y is equal to 2 sine of x plus y divided by 2, cosine of x minus y divided by 2. Again, you'll notice that this particular identity is actually sitting right on our identity sheet. And as I said in the last video, it is not okay for us to say, hey, we're done. Okay, it's on our identity formula sheet, we're done. What we first have to do is prove it. Again, if I provide you with this particular question, you must prove that this identity is true using one of these previous ones up here in some way or another. Now, I'm going to actually go through the way your textbook does it and explain how that is done. And you've got to bear in mind that this is creative manipulation, okay? It's not something that I'd expect you to do right off the bat, but over time, maybe you might recall to let these certain circumstances occur. So, what I'm going to actually work with is I'm going to, again, just pull something out of my butt, okay? I'm going to say, let's just happen to let x equal an alpha plus beta, okay? And again, you have to notice that I'm introducing two new angle measures, the angle measure of alpha and the angle measure of beta, okay? I'm also going to let y equal alpha minus beta. Again, this isn't coming from anywhere. I am simply just saying, hey, let's play with this. Let's see what happens, okay? Now, after I let this occur, I can look at these first two pieces and say, hey, isn't this the sine of alpha plus beta? I can say, hey, isn't this the sine of alpha minus beta? And I can make that statement, okay? So I'm going to go ahead and do that. I'm going to replace x with what it really is by, again, this occurrence. So I'm going to have sine of alpha plus beta plus the sine of alpha minus beta. And this is supposed to be equal to 2 times this, okay? Well, what I'm going to say is x plus y. Isn't x plus y really these two things added together? Let's go ahead and do that, okay? So what is x plus y really in terms of this information, okay? X plus y is alpha plus beta plus alpha minus beta. Well, isn't that really just 2 alpha? Because the betas just cancel each other out. So this is 2 sine of, well, 2 alpha. 2 alpha divided by 2. So that's just going to actually be 2 times the sine of alpha. I'm going to hold on to that piece of information, okay? Let me actually go ahead and identify now what cosine of x minus y divided by 2 is. So x minus y is actually equal to alpha plus beta minus the quantity alpha minus beta. Okay, when I distribute this negative, I'm going to get alpha minus alpha, so the alphas are going to cancel out. I'm going to get beta plus beta, and that's going to give me 2 beta. And when I plug that in, I'm going to get the cosine of 2 beta divided by 2. Again, replacing my x minus y with what it really is. That's 2 beta, so I get 2 beta divided by 2. Okay. Now I have the sine of alpha plus beta plus the sine of alpha minus beta is equal to 2 times the sine of alpha cosine of beta. Now I hope that you're thinking very clearly about this. I'm going to look back to my identity sheet and say I have, well, wait a second, 2 sine alpha cosine beta. Sine alpha cosine beta. I see sine of x cosine of y, and that's equal to 1/2 sine of x plus y sine of x minus y. Wait a second. If I replace my x's with alphas and my y's with beta, and then divide both sides by this 2, don't I get, and I'm gonna write it this side first, sine of alpha cosine of beta is equal to 1/2 times sine of alpha plus beta plus the sine of alpha minus beta. And I hope that you recognize on our identity sheet that is this identity right here, with x's are alphas and y's are betas. Again, This is sine of alpha cosine of beta is equal to 1/2 quantity sine of alpha plus beta plus the sine of alpha minus beta. And that completes problem 4a. Again, we marked that one off. Notice how we started with something that we wanted to prove. We let an angle manipulation occur. Again, you need to know that we're not changing these functions. We're just changing what the angles are denoted as. And that allows us to make these manipulations. Okay? So that completes problem 4. Let's look at problem 5. Problem 5 says we want to write the sine of 4 alpha minus the sine of alpha as a product. Okay, so I have currently a subtraction of two trig functions with two different angle measures. Okay, and I want to actually write it as a product of two different trig functions. Okay, so I'm going to look at my identity, and I have sine of something minus sine of something. So when I look at my identity sheet, it's actually going to be this one right here. Okay, sine of x minus sine of y. I'm going to follow that one to a t. So in this case, my x is 4 theta, and my y is theta. Okay, when I go ahead and plug everything in, I'm going to get that this thing is sine of 4 alpha, theta, minus sine of theta is actually equal to 2 cosine of 4 theta plus theta divided by 2. Okay, and again, just following the identity. You can't see it, but I've got my finger up here following this identity so I don't make any mistakes. Okay, so back down here I have times the sine of 4 theta minus theta divided by 2. Now that I've done that, this is equal to 2 cosine of its 5 theta over 2 times the sine of, it looks like 3 theta over 2. And is there anything else I can simplify? The answer is no. 5 over 2 doesn't break down, 3 over 2 doesn't break down, but the question asked me, okay, to say write it as a product of two functions. There's one function, there's a second function. This problem is done. That is the answer that we're looking for. Okay, and again, notice that this question is not asking you to verify. It is asking you to write it in a different form. I have done so that will be my answer. Okay. Lastly, we're looking at problem 6, and I think there will be enough time to finish this one on the video. So I'm going to actually go ahead and start a new page. The problem is to, again, 6a, verify this identity. Sine of 6x plus the sine of 2x divided by the sine of 6x minus the sine of 2x. Now this is supposed to be equal to the tangent of 4x times the cotangent of 2x. Now, just by noticing something about this, the fact that this is a product and these two things here are additions and subtractions should tell you something. Okay. What I think we're going to want to do here is start with the most complicated side first and simplify this if we can. The way that I'm going to do that is by looking at my identities, and notice that I have sine plus sine, and on my identity sheet, sine plus sine will be equal to 2 times sine times cosine. This should work out for us nicely. Let's go ahead and give it a try. Okay. So I'm going to use that first identity by changing this one here, and I'm going to change it to 2 sine of 6x plus 2x divided by 2 times the cosine of 6x minus 2x divided by 2. Okay. Now, I'm going to also divide this by this thing here, utilizing the other identity, the sine of x minus the sine of y, this one right here. Okay, so when I do that, I'm going to get 2 cosine of 6x plus 2x divided by 2 times the sine of 6x minus 2x divided by 2. Now, if you're good with verifying identities at this point, some of you right here can see the connection from this point up to this point. Okay, if not, let's work through some of these details. The 2's will cancel out. I have sine of 6x plus 2x. 6x plus 2x on the inside is actually 8x. Okay, but on the inside I'm also dividing by 2. Again, that's that top piece. Then I have the cosine of 6x minus 2x, that's really 4x divided by 2. And then on the bottom, I'm going to have the cosine of 8x divided by 2, and the sine of 4x divided by 2. You'll notice that these angle measures are actually matching up quite nicely. Okay, I end up with the sine of 4x times the cosine of 2x divided by the cosine of 4x, the sine of 2x. Wait a second. Isn't that just cotangent? And isn't that just tangent? So this becomes the tangent of 4x, and this other piece becomes the cotangent of 2x, because the angle measures match up. That's the only reason why I can say that this thing right here is cotangent. And the only way I can say this is tangent. And then you'll notice this all the way back up to here verifies that identity. That finishes problem number 6. We will look at the next problem on the next video.